Welcome to Brain Vision.
We need to find the value of the force that the point B exerts on the jaw of BC. And we also need to find the value of this moment about the rod. So I drew 3 different free body diagrams, one for the jaw, one for the nut, and one for the rod. And notice that I added in a point D. This is where in the given figure, this is where the nut makes contact with the rod. So these 2 points here are both connecting. So to start solving this problem, we're going to first look at this free body diagram to the left and take the sum of moments about the point B. So the sum of moments about point B is equal to 0, which you can write as the x component of the force C times 1.5 minus the y component of the force C times 5/8 is equal to 0. And solving this expression for C of y, we can get a value of C of y that is equal to 2.4 times C of x. And now we're going to say that the sum of forces in the y direction is equal to 0. And from the free body diagram, we can say that B of y minus C of y is equal to 0, which we can write as B of y is equal to C of y. And we can do the same thing in the x direction. So we take the sum of forces in the x direction is equal to 0. Write that C of x minus B of x is equal to 0. And we can also say that B of x will be equal to C of x. So we're now going to look at the free body diagram of the nut. So from the nut, we can say that the sum of forces in the x direction is equal to 0. And we can write it as C of x minus the x component of the force at D is equal to 0. And then we can say that C of x is equal to D of x. So we're now going to take the sum of moments about the point D on the nut. So the sum of moments about the point D is equal to 0, which we can also write as sum of moments is equal to D. The sum of moments about the point D is equal to C of x times 1.125. And the problem gives us this value of the sum of moments, which is given as 135. So we can plug in 135 is equal to C of x times 1.125. And solving for C of x, you can get a value that is equal to 120 pounds. And this is also equal to B of x. And since we know this value of C of x now, we can plug it into this term here, and then solve for the value of C of y. So after plugging in, we get that C of y is equal to 2.4 times 120, which is going to be equal to 288 pounds, which is also equal to B of y. Now to solve for this force, the force at point B, we can take the square root of the x component squared plus the y component squared. So we'll get that B is equal to the square root of 120 squared plus 288 squared, which will give us a force value of 312 pounds. And that completes part A. So now for part B, we're now looking at the free body diagram of the rod. So we're looking at this one. And to solve for the unknown moment, we'll say that the sum of moments about the point D is equal to 0. And we can write it as negative m naught plus b of y times 0.625 minus b of x times 0.375 is equal to 0. And we can plug in the known terms and solve for m naught. So we get that. So we get negative m naught plus 288 times 0.625 minus 120 times 0.375 is equal to 0. And solving this for m naught, we'll get a value of 135 pounds inches, and this is going to be in the clockwise direction.